For Rust, so there are four different the parameters on which we call Rust as important language in Visual Control. So first one is low resource footprint. So when we say resource footprint, footprint means the total consumption of any resource. So for running a single piece of code, how much? What is the amount of CPU usage? What is the amount of memory usage? How much data it is storing on the device itself. So these are the measures that we consider while considering the footprint of any language. So Rust has very low footprint. So it's a high level programming language, but it has the capabilities of a low language. So it runs on bare metal. So when we say bare metal, it doesn't mean this metal. It means we can run it directly on the hardware itself. We do not need any other environment to run. Then it's memory safe. So we'll look at memory safe in upcoming slides more. Then it has a steep learning curve. So for learning any other language, for example, Python is very easier to learn because the core concepts, so the topics on underlying principles of Python are very easy to understand for a beginner. But so when we start learning development in general, so first we start with Python, then we go for C++ or Java to learn the OOPS concept, and then we start with the logic middle and DSL further. But if you want to start with Rust, we do not need those existing concepts from the other languages. We need to start from scratch. So even if we have an experience of 10 to 15 years in other languages, if you want to start programming in Rust, you need to start from scratch completely. So those concepts are not carried forward. So that's a steep learning curve. Next. So let's look at a certain use case over here. So this graph is for just for the boilerplate. So if you want to run just a hello world that consumes just one thread, and so these are this is the amount of memory that each piece of code in certain language will consume. So for Rust, if you are creating a single thread in Rust using Rust threads or Tokio or Standard, so these are the libraries using which we can create threads. If you look at comparison, C# has the highest footprint, so it consumes more than 120 megabytes of RAM, and Rust consumes around 2 to 3 megabytes of RAM just for the hello world. And Python is comparatively low, but C# has the highest. Can we move to the next one? Yes. So this is the same graph, but with 1 million different threads running parallel to each other. So here you can see C# is the lowest, one of the lowest, and it is comparatively insane with Rust. But Python spikes up and also the Go. So what do we understand by here? So for Rust, if we keep on increasing the number of threads, if we keep on increasing the parallel processing, this spike was in 45 or something. But for C#, so the upfront cost for resource for C# is very high, but then it gradually decreases even if we spike up the number of threads that we are running. So using this or just looking at this matrix, we can say that Rust and C# are nearly the same, but it's not the case. So for running this same piece of code for each and every language, we need a runtime environment. Okay, so for running the same piece of code in C#, we need the entire operating system underlying it. For Node.js, we need entire browser on top of the existing operating system. So the overall resource consumption of that piece of code or that piece of application increases dramatically. Not just that code, but the environment itself. But Rust, since it runs on bare metal directly, we do not need any extra resource consumption for that same project. Can you go? Yes. So let's look at the layers. So on the last we have the hardware layer, and on top of the stack we have the JavaScript. So for a single console log of hello world in JavaScript, we require all of these layers to exist underlying the environment, and each one of the layer has its own host. So yeah, so and we can also run Rust inside the browser. We will look at it in the upcoming slides. If you look at the, so this is the user space. So user space means user applications, and this is the system space. So system space means system applications. System applications like control panel, settings, and all those things. So if you look at the system space, user space and kernel, three of them are the part of any single operating system. So if you remove the user space and just keep the system space and kernel, that will become just two of these. So that will become the part of an embedding system. So in embedding system, it is designed for a mission critical application, and it just does the job it is designed. User cannot add more functions to it, so the functions are limited. And the same thing for embedded systems, user application will be like, it's like a kiosk or something. So kiosk is, if you go to McDonald's and if you look at the same concept, you can place an order, but it cannot even place a category on it, even though it has Android inside, but still that user space doesn't exist over there. So that's the embedded system. Now until kernel, so that's the OS. So until kernel, the entire space is for OS. So this is completely software and this is completely hardware. The BIOS part, we call it as a firmware. So it's not neither soft, neither hard, it's firm. So if you start working with the firmware, it somewhere merges with the embedded system as well. So generally people use open source and UEFI and basic firmwares for the embedded systems, but even that less. So the reason for explaining each layer is we can write a single piece of logic in Rust and use that exactly same code at any layer like present over here. So that's the beauty of Rust. Now let's look at how this is useful in Industry 4.0. Okay, so now if I'm developing a PLC, writing code for a single PLC or something, then currently it is written in C and C++. So in C and C++, we need to manually manage the memory usage. And if we try to write it in C# or something, then it has a C# or Java, it has a garbage collector in it. So these are two different ways. So for manual management, the developer defines the allocation and deallocation of each variable. But for garbage collector, if the developer doesn't need to worry about it, the environment takes care of it. So in Rust, we don't require any of this. So we don't need to worry about the memory, and neither does the environment need to worry about the memory. So the language itself takes care of it. No human error. So for example, if you write a piece of code and you declare a variable and then you don't use it at all. So if you write that in Python, it won't care to notify you at all. But if you write the same piece of code in C# or something, then it will give you a warning that you have declared a variable, you initialize it, but you haven't used it anywhere. But if you are using same thing in Rust, it will not compile at all. So the rules, the strict rules of the Rust help us to eradicate the human error, and it helps manage the memory even better. Then more predictability. So let's consider we have a big project like an entire operating system, like Windows itself. So that entire project has many small pieces of components, and each component has lots of pieces of logics written in it. Now if you want to do semantic analysis, or if you want to analyze the entire code base and see what are all the possible outcomes that can go wrong, then it will take take several years for each release. So that will be not a great idea to do it, but we do it anyways and just go ahead with it. And then there are there are several bugs in the production itself, and then you fix it. But if you write the entire operating system inside Rust, then there will be no possibility of memory errors occurring at all in the production. So that's why there is more predictability. For C and C++, we can't predict if something may or may not work out. Here we can predict. Then we have the flexibility. For flexibility, we look at so we have the flexibility of running the same piece of code at any layer. So that's the flexibility, and the community is good. So if you have any issues, so there are two organizations. One is the open source community for Rust, and the other is the defining community, the one creator of Rust. So if you have any doubts or any questions related to the language, you can reach out to any of them. And